Hello and welcome to the series that I'll be doing on IPv6 tunneling. So in this particular series, I'll be covering how to configure the different IPv6 tunneling options. I'm referring to 6RD, 624, 6 using the new Sophos XG firewall. So if I have the chance, I may also extend this to the Sophos UTM. So in today's video, I'll specifically be focusing on and the 6RD tunneling technology on the Sophos XG firewall. And my main reason for picking 6RD first is to reply to some community posts on the Sophos community page. So if I link up websites now, and to reply to these two posts on the Sophos community page regarding people that need some clarity on how to configure 6RD on the Sophos XG firewall. So just to show you briefly the topology that I'll be using today. So I'll be using GNS3 integrated with VirtualBox, and I have two XG firewall on both ends, and I'll be going into this in a bit more details later. So for now, I will just start the topology rolling, and then let's do a bit of some discussion before proceeding. Okay, so before starting also, I'd like to make special mention of this awesome blog series on Intense School. I'm not sure if you're aware of this online blog called Intense School. So they've got like this really good blog posts. Let me bring that up also. So on all these links that I'm posting in this video, I'll be putting them in the description below for this video so you can refer to them later. So this is Intense School, resources.intenseschool.com, and if you just search Google Intense School IPv6 tunneling, and then you get this series, and it's a 7-part series by a guy called Adeolu Owokade. And I must confess that this has been a really good blog series for me in terms of helping my understanding of these different tunneling technologies of IPv6, and I'll strongly recommend you to just go through the entire blog series as I have done also. Okay, so let's get right into 6RD and that I'll be talking about today. Again, focus of this video, how do I configure IPv6 6RD tunneling on a Sophos XG firewall? So just some basics first of all around 6RD. So I'm a firm believer in IT philosophy. In other words, you have to understand the reason for the existence of a technology before you can use it effectively. You have to know what problem this technology was created to solve. So it's the same way. So in IPv6, we have different tunneling technologies that you could use. So just to give a quick explanation of that. We currently, the internet is mainly IPv4 for now. So we won't just shut down IPv4 internet tomorrow and all of a sudden all of us are on IPv6. So there has to be a transition between IPv4 to IPv6. And there are different technologies that makes that available. So one of the technologies that makes that available is the dual stack. And that's just referring to different computers or network devices or network capable devices that support both IPv4 and IPv6. That is, they can pass through IPv4 traffic at the same time they can pass through IPv6 traffic. So that's what we refer to as dual stack. The other one are the tunneling technologies. And there are different types. So there's the 6RD, which is the one we're talking about today. There's the 624, and there's the 6-in-4, and there are others. There's ISTAP. Some will even argue there's Tornado. All right. IPv6 tunneling technology. So what you've got, like for example, is you've got an IPv4 network, and you want to pass IPv6 traffic over an IPv4 network. So what you have to do is encapsulate that traffic, encapsulate the IPv6 traffic in with IPv4 headers, so that you can pass through an IPv4 network. IPv4 based network. And all these technologies are a form of that in one way or another. So, and then also we have some translation technologies, which will basically just translate IPv6 headers and translate them into IPv4, but we won't be getting into that one at all for now. So back to 6RD. What exactly? So 6RD stands for 6 Rapid Deployment, IPv6 Rapid Deployment. And what's the reason? Why does IPv6 rapid deployment, why does it exist? So best way to know why it exists is let's go to the RFC and check out some information on the RFC. So if I go to that, and then I'll just expand this for you to make it easier to see. And then right here is what I want to focus on. It says this document and specifies an automatic tunneling mechanism tailored to advanced deployment of IPv6 to end user via a service provider's IPv4 network infrastructure. Okay, let's bring up another RFC. And let's go. And let's see. Yeah, IPv6 rapid deployment on IPv4 infrastructure built upon mechanisms of 6 to 4 to enable a service provider to rapidly deploy IPv6 unicast service to IPv4 sites to which it provides customer premise equipment. Now that's important. So there's a reason why I have brought you to this page, is because this will clarify a lot of issues that I've seen many people have with IPv6 6RD. 6RD was mainly geared towards service providers when it was created. So it's not something that's just geared towards enterprises, it's geared towards service providers. So what do we mean by this? What does all this statement, what does it mean? It means the main reason why IPv6 6RD was created, the main reason why it exists is to enable service provider to be able to easily provide their customers with IPv6 networks without them having to scrap their entire IPv4 infrastructure. Again, let's break that down a bit to make it more understandable. If I bring up this diagram that I have here, so again, let's look back to that document. It says enables a service provider to rapidly deploy IPv6 unicast service to IPv4 sites to which it provides customer premise equipment. So what does that mean? I'm an enterprise, I have a site here, right? So my ISP provides me with this customer edge equipment. So this equipment does not belong to me. This equipment belongs to my ISP, and they are providing internet access for my enterprise. So they provide me with this, but what they want to do is to be able to quickly provide me with an IPv6 network. But then this ISP has made a lot of investment in IPv4, so their entire or majority of their infrastructure is based on IPv4. So does that mean for them, in order for them to be able to provide me with this service, they have to scrap all the existing IPv4 network that they have a lot of investment in? They've done a lot of refreshes and stuff around that. So do they have to scrap all of that in order to be able to provide me with IPv6? No. So they can leverage the existing investment with IPv4 based equipment while still being able to provide me with a full-blown IPv6 network inside my enterprise. That's why 6RD exists. So what will happen is the ISP will give me this customer edge equipment, and the ISP will have their IPv4 network here, and they will have right here, they will have their ISP border router, and the ISP border router is the one that's connecting to the IPv6 internet. Whereas the customer edge equipment that the ISP has put on my site, the outside or the egress facing interface is configured for IPv4. The ISP border router that connects to the IPv6 internet, the internal, the reverse-facing interface is configured for IPv4. So in other words, they can use all the existing IPv4 infrastructure, and all they need to be able to now start providing me with an IPv6 network is to have a dual stack equipment here as my customer head and a dual stack equipment here as the ISP border router. And guess what? The Sophos XG firewall that we'll be talking about today supports dual stack, and that's what we'll be doing our configuration on today. So I hope that was really helpful to make you understand that a bit. So again, my strong recommendation would be go through the blog post on IntenseCool that I mentioned. It will definitely help you. I must also mention that at some point I will also be creating some IPv6 basics video. So this is not the end of, this is not the only video in this series. This is just on 6RD. I'll be doing another one on 6 in 4. I'll be doing another one on 6 to 4 also. Okay, so let's move forward a bit. So now I've got my network here. So let's go back to the topology that we'll be configuring today. So we have all this fancy virtual box. By the way, if anyone from GNS2 is watching this, love you guys. GNS2 is an awesome product for those that don't know. Just a really awesome product. I mean, just Google them. They've been around for a long time. I've been using it for a long time. It's just a very awesome product, and the kind of improvements that has been done more lately, it's awesome, and it's free, and it's integrated with VirtualBox, which is free also. So here we have a sample of what we'll be configuring today. So we have the Sophos Firewall here acting as a customer edge equipment, and here we have the border router that in this case, because there's a lab environment, let's assume this is connecting to the IPv6 internet. So let's just, for the sake of this lab, assume that here is a IPv6, here is a IPv6 internet right here. Let's just assume here. So this O1 here, it's IPv6 internet. Okay, so IPv6 internet right here for us. The border router that's connecting to the ISP's IPv4 network and to the IPv6 internet is over here, using the Sophos XG firewall also in this case. The customer edge equipment, so I'll put another eclipse here to indicate that this is the customer edge. Sorry, this is the enterprise network. This is the customer's enterprise network that this ISP is providing a service to. Now lower by one layer. So customer's network here. Let's make that clear. Enterprise network. And this enterprise network, what this ISP wants to be able to do is they want to be able to provide this with just pure IPv6 network. Now this device over here supports IPv4 and IPv6 just like Sophos XG firewall, so it does the same on both sides. So what we'll do is we just begin with the configuration. So one of the first things that I need to mention also, not the first thing actually, because I've talked about a while now, the things that we need for the configuration. Or let me adjust that to make it better. So let's now say the things, the information that we need for the configuration of IPv6 6RD on the XG firewall. So what information do we need? Number one is something called the IPv6 prefix. And this is what this just refers to. Actually, let's just bring up the RFC again, and it will help us to understand this. So RFC again, let's go to the terminology section. There we go. Terminology sets out the prefix. An IPv6 prefix selected by the service provider for use by a 6RD domain. there's exactly one 6RD prefix for a given 6RD domain. What does that mean? So the service provider may deploy 6RD within a single domain or multiple 6RD domains. What does that mean? This just means this information is provided to you by your ISP. This is the IPv6 network that you will be joining in your 6RD domain. This is the IPv6 network you'll be joining. Where do you get this information from? You get this information from your ISP. So provided by the ISP. So that's the first thing we need. Number two thing that we need is we need our external facing IPv4 address of the CE, of the customer edge equipment. So 6RD customer edge, a device functioning as a customer edge router in a 6RD deployment. In a residential broadband deployment, this type of device is sometimes referred to as the residential gateway. A typical 6RD CE serving a residential site has one side interface, one or more LAN side interface, and a 6RD virtual interface. This is what we'll be configuring on a Sophos Firewall, 6RD virtual interface, or the 6RD tunnel. So a 6RD CE may also be referred to simply as a CE within the context of CLD. So back to our topology that we're configuring today. So that's the CE there. What's the external facing IP address? In this case, we have 192.168.10.2, which is this one, and that's the that's this information here. Okay, let's move on. What's the next thing that we need? Next thing that we need is we need the delegated prefix. Now this is where it gets confusing for some guys. Again, I'll strongly recommend the Intense School blog post. So delegated prefix of the ISP's border router. What does that mean? Again, back to this equipment, this topology. So after we configure, when we're configuring our customer edge equipment here, one of the things that we want to do is we want to make this border router as the gateway. So in other words, any traffic that's IPv6, send them to this gateway. But for us to make that configuration, we're going to have to use an IPv6 address of this equipment here. And that IPv6 address will be something referred to in IPv6 as a delegated prefix, and in 6RD as a delegated prefix. This is not like an ordinary IPv6 address. This is basically an IPv6 address that has information of the external IPv4 address embedded in it. So that's what it means. So the IPv6 address that will be providing to this guy, there's a way that this equipment will be able to pull apart the IPv6 address and say, okay, this IPv6 address that you provided to me as my default gateway is actually pointing to this external IPv4 address, which is 192.168.20. And it's something that can be automatically calculated, or something that you can manually calculate as an administrator. Just to give you an illustration, let's say you got an ISP providing you with an address of, let's pick the same one that we'll be using in our lab. Let's say 2003 AABB/32 is what we have. So let's go 2003 AABB/32. That's what we have as our prefix. Now our external facing one is, in this case, 192.168.10.2. So I'll just put that there. So 192.168.10.2. And so from this information, how do we get our delegated prefixes? Well, simple. What we do is we have a prefix here. That's the starting point. It starts with the same prefix. But now this information, we have to embed it in this address. So we do that by converting this address information into hexadecimal. So how do we do that? Again, we have 192 here. So let's bring up just a page here that will help us to go decimal to hexadecimal. And let's go to this. And let's just make this a bit smaller for us and bring this up here. Okay, so I've got 192. If I go 192 here, decimal value, convert to hexadecimal, I have C0. So here I'll put C0. Then I have 168, okay? So let's go back to that. So I have 168 convert that A8. So I put A8 there, colon. So then I have 10. So let's calculate that again. 10, that's A. Okay, so that's A, that's a single character, but so 0 here. And then finally we have the 2. So if we go back here and say we need 2 converted to hexadecimal, it's also equals to a 2. So that's 0, 2. So that's 0, 2. And then if we calculate this, is 4 bit each, so that makes it 64 bit. So that's /64, and that will be our network, our internal network, and that will be the same on the other side. So that is on our side. On our one, that would be our delegated prefix. What about on the ISP side? Well, the ISP, again, we need to provide you with this information, because let's do the same. So external facing one of well, in this case it's not one, or just ISP IPv4 interface on the border router, and that's 192.168.20.2. So if I go back to diagram, we're using 192.168.20.2, and that's this one. So that's nice information. Then we can calculate the delegated prefix. Again, we just start with the prefix, and then we go 192, we know that's C0. 168, we know that A8, column 20, so we need to get the conversion of 20 to hexadecimal. So change that to 20, and that's 14. So I'll go 14, and then 2, of course, is 02, 1402. And that will be the ISP's delegated prefix. If we bring up the RFC page here, and let's go to delegated prefix, the IPv6 prefix calculated by the CE for use within the customer site by combining the 6RD prefix and the CE IPv4 address obtained via IPv4 configuration methods. This prefix can be considered logically. So basically what it's just saying is what we've just discussed, where your IPv6 or your IPv4 address is embedded within the IPv6 traffic, and you can go through this. So there's a way to also provide that information via DHCP, but won't be going into that today. Okay, so now that we have that information about those are the core things that we'll be needing, then we'll get right to it and then start doing our configuration. So let's bring up our lab in JNS3. I'll log into the Windows 10 one machine here, Windows 10 2 machine. So let's log into both of them. It's Windows 10 1 and Windows 10 2. Oh, so that's okay. So first thing that I'll do is I'll just do some basic configuration on this firewall here, the customer edge equipment. So what we'll be doing again, remember we just calculated the delegated prefix of this. Again, we're just using this in lab environment to simulate the IPv6 internet, so that's why I'm calculating the delegated prefix. For the ISP, this will just be pointing to straight to the internet. but you will still need their prefix here in order for your device to know where to send the packet to. Because inside this address is embedded the IPv4 information. Okay, so it's 0A02, so that's for the customer edge. So let's copy that. And I need some text here. There we go. So that'll be this network here, this internal network here. And the same goes for the border router, because again, remember, we're just simulating IPv6 internet here, and that's for this one. Okay, so this one will be .1, this will be .2. So what I'll first do is just make sure that the IP address configuration on all of both these interfaces, or these 4 interfaces, are accurate. So let's go to that. So I'll log into the customer edge UTM 172.16.16.16.4444, and why that's coming up, I think I'll do the same on this one. So that's HTTPS 172.16, because that's the default address that the XG firewall uses for the LAN address. So I got that. Maybe to even ping this. So that's my number 1 machine. So maybe I need to restart something. Yeah, I'll just restart the Sophos Firewall 1. Yeah, I'll just restart it. So what I'll do is I may pause this video to do that, so as not to make it go too long. So the only thing I'll be doing is I'll show you how to do the first one, and I'll just pause it to the rest, and then we'll carry on with the recording. So just go through this, go to the network interface. So first thing I'll do is I'll first of all make it use both IPv4 and IPv6 address. So this is the one for the border router. So that's 2003 AABB C088 14022. So that's what I'm configuring. So I'll copy that, and I'll make sure I enable bidirectional keyboard. Copy it again. Let's put that here. So I'll just change that to a 2, because that's the address that we have on a diagram here. So this is .2, this is .1 here, or column 2, and I'll save that. If I do that, I'll copy this, and then I'll go to this client device, which is this guy over here. So, and then I'll go configure its IPv6 address. And in this case, we're using column 1. Again, according to our diagram, we have column 1 here. So column 1, prefix is 64. Give it the default gateway of column 2, which is the UTM, and I click OK to that, and OK. And yep, okay with that. If I go to just do a quick ping to the IP address of the UTM, now I can ping it. So now I can connect to the UTM using its IPv6 address. And the way I do that is by going to HTTPS :/. I have to put it in a square bracket, different from IPv4, and then column 344. So I think I missed HTTPS. Yeah, here we go. So now I'm connecting to the UTM, on using IPv6. And then what I can do then is I can remove IPv4 completely from the LAN interface. Then go, I don't have to do that if I want to use drawstack, but for this demo I'll do that. Done on the UTM, let's go do that on the computer itself also. So I'll just remove IPv4 completely. Okay, so this is just plain IPv6 network here. So what I'll do is I'll pause this recording and do the same on this other side. Hello, yeah, so I'm back after finishing the initial configuration. So right now what we have is we have this network fully configured for IPv6 and this network fully configured for IPv6. So if I go back to this client over here, you can see I'm connecting to the UTM of our IPv6 over its IPv6 address, which is A02, which is what we have here. So with the 0 with IPv6, you can always remove the preceding 0. So and here we've got on this other side we have 1402 colon 2 for the UTM, and that's what we have configured on this other side also. So I'm connecting to it on that side. So you can see from here also the device is able to ping itself. It can ping its gateway, which is the UTM, but when it tries to ping on the other side, which is this one, so it tries to ping the device on the other side, could not ping it. It tries to ping the UTM on the other side, could not ping it, and the same on this side also. So ping itself, ping its gateway, could not ping anything on the other side. So what we'll now do is we'll go first of all to this device here and configure 6RD tunnel. So let's do that. So right now I'm on this device on the customer edge, this device connected to the customer edge LAN. And what I'll do is I'll go on the system, I'll go on the network, and I'll go on the IP tunnel. So on the IP tunnel, I add a new tunnel. So the thing that you find out actually with this is that the configuration is not actually complex once you have an understanding. The challenging part is getting that understanding. So I change this tunnel type, I select my 6RD. My prefix again, which is something provided by ISP. Delegated prefix is a subset of the prefix provided by the ISP. So I'll put that /32. So one thing to mention is that this is something called the global address in IPv6, which means it's routable on the internet, sort of like a public IP address. So for the zone here, I'll select it, put this into LAN zone because it's internal. 2003 AABB column 32. Local endpoint will be which endpoint does this tunnel go out from. So I'm on this device here. So it's going to be going out from this interface, and this interface has an IP address of 192.168.10.2. So that will be the local endpoint that I'll be giving to this. So if I go back, see 192.168.10.2, and I can set some advanced settings in terms of TTL or type of service, but we'll get into those later. So you can see remote endpoint is grayed out because that's one of the questions on the community page was, why is this grayed out? If we understand 6RD, there's no need to configure this. So this is not 624, this is different. So all we need to know now is, again, back to like the list of what we said we need to know. We've got a IPv6 prefix provided by the ISP. Let's see, that's configured there, good. We've got external facing IPv4 address of the CE, good. That's what we've configured here on the local endpoint. Delegated prefix of the ISP's border router. This is where many people fall, is because they don't have the information here of what's the delegated prefix of this border router that's connecting to the IPv6 internet. Because during this configuration, and you see what I mean, it's going to ask us, do you want to configure any route? And many people, because they don't understand this, just click, okay, yeah, that's all right, forget about that. And then like, how come it's not working? It's because we have to get this information from our ISP if we don't have it, and we have to configure that as a default route on this device for that to work. So now we know what the delegated prefix of this is, which is this address column 2. So I'll copy that. This address column 2. So let's go back. So I click save to that, and instantly tells me, see, I've added a route for this. Do you want to add any more routes? People just click, just save or cancel, don't. This point, what you need to do is you need to either phone up your ISP, get your ISP to give you the gateway. So what I'll be doing now is I'll be configuring this as both like a border router situation or another customer edge situation. So I'll add a route to an IPv6 network here. So that is this network on the other side. So I'm saying anything going to this network on the other side, I want you to send it to this interface, which is this address column 2, which is this IPv6 interface of this border router. So that's what I'll be configuring here. So I'm gonna go and put the next up there, column 2. And then I'm going to add another one because this is what you'll be doing if this is not another customer edge, if this is just an ISP situation, default gateway situation going out to the internet. I configure that, I go column, and I say anything going to anywhere IPv6 wise, default route, send it to the other side, which is the delegated prefix of the border router. That information is important. You miss this, your tunnel is not going to work properly. So important to note that. So done that, I click save. So I've got that correct, and I click save, and then it tells me I've added the routes that you've mentioned. Good. Actually, if I wanted to, I could go in the backend to view the routes. I won't for now, but I could. So that's to know that. Okay. So then I go on the other side and I configure something similar on the other side. So if I go on this other side, what I want to do on this other side is also configure it kind of like a customer, as a proper customer edge scenario to say anything going to this network here, send this to this IPv6 interface here. So that's what I'll be configuring on the other side. So let's go to this one. I go network IP tunnel, add a new tunnel border router 6RD. Select 6RD also. Again, the prefix, because this is configuring from the ISP side now, select the same prefix. Learn. So in this case, it's going out from interface 192.168.20.2. So I've got to enter that correctly, 192.168.20.2. Can configure advanced settings if you want. There's no option to configure remote endpoint because again, remember the 6RD, it's not needed. I save that. Again, don't go ahead and just click cancel here, or again, you need the information from here. You need this delegated prefix information of this customer edge equipment. So this is configuring from the ISP side. So what I'll do is this information here, I'll copy it. And I'll go back. I'll say anything going to the customer's network here, anything going there, send it to the UTM's IPv6 interface, which is column 2. To anything going to this network here, send it to this network interface, column 2 here. And there's really nothing else to configure because this is not, so the ISP is not using the customer's edge equipment as a default route. There's nothing to configure apart from this one. So I click save to that. Good. Okay, so now let's go. So now we've gone past the first hurdle which many people miss, which is the failure to configure the proper unicast route to get to the network that they're trying to get to, or to get to the ISP border router that they're trying to get to get out to the internet. So they've configured that, so we've passed that first loop. So the next thing is, now let's see, can we now ping the other side? So I'm on this side now. I'm on this side. Can I ping just this interface on this other side? And if I go back to there and I try to ping it, you see it's still not successful. Now, one good thing about using GNS3 with Wireshark is we can do packet captures. So if I start a packet capture on this interface here, and see what's going on. And what I'll just do is I'll just limit this to ICMP version 6 packets, because that's what I want to see. And if I go back again and just do a ping, so yeah, so let's go back, nothing. So now that should be really straightforward for a network admin to know what the issue is there. The issue now is we have this tunnel and this route configured, but we need firewall rule to allow the access. So I have to go under security policy, go under IPv6, and then add a firewall rule, use the network firewall rule. Add one at the top. Now, don't do this in a production environment. This is a lab environment. I'm just testing. I don't really care too much. You have to lock this down more than what I'm doing here. I'll just call this any IPv6. No user identity. Say anything going from zone any to any. Just allow that. Accept, right, okay. Now save that. Now I've done this on this interface here, on this one here. So I have to do this on the side of the ISP too. So again, let's go to IPv6. Remember this IPv4 firewall table, this IPv6. So we go back to top, any IPv6. Remove that, and I'll just add any to any. Another warning, don't do this in production. This is just in tiny lab environment that I'm gonna be destroying after this video recording. So any rule, and I'll just save that also on this side. Now if I go back to do my ping, aha, nice. Now I'm seeing traffic passing, and that's very interesting. So that is me pinging this interface of this UTM. What about this device here? From this side, can I ping it? Let's go back to the side and let's go. Oh, sorry, I'm actually pinging that device as colon 1, so I can ping the UTM's interface too. Nice. What about if I go to the customer's network? Can I ping the border router of the ISP? This one. Can I ping this? Let's see if I can ping this. Let's go to this 1402:1. Yes, I can ping it. And can I ping the device on the other hand, which will be synonymous? Yeah, there we go. I can ping that. Now let's just do a bit of check on what's going on within Wireshark. So you can see the pings are going through. The source is coming from column 192.168. Aha, delegated prefix. Remember what we said, IPv4 address embedded within the IPv6 address, and that's going to this, because if we actually go and dig deep into the packet, we've not actually configured anything to say anything going to this network, send it to this IPv4 address. We've not actually configured that. But actually, if you think about it, we have. Once we configure that route with the delegated prefix, we have configured that, because inside that delegated prefix with the next stop that we configured is embedded the IPv4 address of the other side. Remember that. And then instantly this device can calculate and know this packet going to this IPv6 address. Where I'm to send it to is I'm to send it to 192.168.10.2. So it embeds it in the IPv4 packet. IPv6 is within that, delivers it to the other hand, strips away the IPv4 packet, knows where to send it to IPv6 wise, and sends it there. So I hope that's been very useful for you. Again, check my channel in a couple of days time and I'll have a recording for 6.4 and 6.4 also. So I hope this has been very useful for you, and I'll see you later. Cheers. Bye.